G? Yeah, it is. So here I have two equations. Example number 4. These two lines give us the same slope. Come back. Both lines give us m equals 2. One of the line has y-intercept at positive 3, and the other one has a y-intercept at negative 4. If it is possible, get a graph paper to do it. That will make it easier for you to see the problem. But for now, I have y-intercept at 3 for the first line. And the slope here equals 2. Up by 2, run by 1. Up by 2, run by 1. And if I can do the same thing on the other side, here is one more point, here is another point, I can come up with one more point here. This is the line for the first equation with y equals 2x plus 3. Here is a second equation. Let me draw it with a different color. Negative 4 for the y-intercept. Here is negative 4. Slope equals 2. And y-intercept equals negative 4. Here is the line for the second equation. Y equals 2x minus 4. And if I want to find the vertical distance, yes? The vertical distance between the two lines, simply compare the y-intercept. One of them has y-intercept at negative 4, and the other one has y-intercept at 3. The vertical distance here will simply be 7. Vertical distance. I can come up with these two numbers, negative 4 and positive 3, by finding the y-intercept. The y-intercept of your line can be calculated by substituting 0 for x. When x equals 0, I have negative 4. When x equals 0 for this line, I have y equals 3. So that 3 and 4, negative 4, will give us a difference of positive 7. Using the same concept, I can now calculate the horizontal distance between the two lines. We need the x-intercept. I want to come up with the x-intercept of this line and the x-intercept of that line. Well, the x-intercept here happens when y equals 0. And solving for x, you have x equals 2. And if you have a graph paper here, you can probably see this point exactly on the x-axis at x equals 2. And for this point on the blue line, the x-intercept happens when y equals 0. Solving for x in this case, I have negative 1.5. So the difference between the two of them will give us 3.5. Pretty straightforward. Now, what makes it difficult is the next one. Find the shortest distance between the lines. Compared to the last 3 example, where we have a point given to us and we use that point to draw a perpendicular line. We are having one line drawing another line to the on the other side. They don't give us any point to work with, but instead they give us a line, and they want us to choose a point to find the shortest distance. Now it really depends on your preference in this case. Some people like to start with one line or the other and draw a perpendicular line from the y-intercept. Some people like to use the x-intercept instead. For me, looking at this question, given I have the y-intercept on one line, if I already know the coordinate of this point, I may as well choose this point to start with and draw a line perpendicular to the other one and find the distance. But I need the equation for this perpendicular line. This line in gray will give us -1/2 for the slope. The slope on this line is 2, so the gray line, the silver line, will have slope -1/2. And here, since I have the y-intercept, it makes it a little bit easy for us to come up with the equation. And once I have the equation of this line, I can now calculate the coordinate of this point using the silver line and the red line. That's the point where they intersect. -1/2 of x plus 3 equals 2x minus 4. And I can solve for x. And of course, do the same thing for the y coordinate. Make a substitution back to one of the two equations here. And I can then use my distance formula to find the distance between these 2 points. Which give us 2.8 and 1.4. The difference between the x and the difference between the y coordinates. And in this case, on my calculator, 2.8 square root of 2.8 square plus 1.4 square will give us 3.13. Now once again, you can use the formula that I've introduced back in example 3 to check your work. And here the biggest concept of this question is to pick a good point to start with. In this case, I used the y-intercept on one line to do it, because this y-intercept will make it easier for me to write the equation for that perpendicular line. But if you were to just randomly choose a point here, let's say, if you were to go with 1 and 5 in this questions and create your equation for this perpendicular line, you'll be using the slope point form instead, which involve more calculations, and that wouldn't be as convenient as the y-intercept that we picked at the beginning.